The moment you type a query into Google Search and hit enter, you trigger a complex and finely tuned system involving dozens of technologies working in milliseconds to deliver results. It feels instant, but behind that blink lies an intricate process that spans network protocols, global infrastructure, data centers, and smart algorithms. Let's break down what happens behind the scenes, from the instant you press that button to the moment you see results. It starts with your device sending the query to Google servers. But before that happens, the domain name google.com must be translated into an IP address. This is where DNS, Domain Name System, steps in. Think of DNS as the Internet's phone book. When you type in a domain, your computer asks a DNS resolver, usually provided by your ISP, to find the IP address linked to that domain. If your computer already has the address cached locally from a recent visit, it skips this part. If not, the resolver goes through a hierarchical lookup process, possibly querying root servers, top-level domain servers like .com, and authoritative name servers until it finds the right IP. Once your browser has the IP address of Google servers, it initiates a TCP connection, specifically over port 443 for HTTPS, performs a TLS handshake to establish an encrypted session, and sends your query over the wire. This query is routed through the internet via load balancers, which are systems that distribute incoming traffic across multiple Google data centers and servers. These balancers decide where to send your request based on real-time factors like server load, network latency, and geographic proximity to ensure the fastest possible response. Once your request reaches a Google front-end server, things start moving quickly. The first check is caching. Google aggressively caches common queries and results. If your search is something popular like weather in New York or Taylor Swift age, chances are Google already has a pre-computed result ready to return. This cache sits on edge servers close to users worldwide, so the results can be served almost instantly without recalculating. But for unique or less frequent queries, Google goes deeper. Your search request is passed to Google Search Infrastructure, where it's parsed and analyzed. This involves understanding the query intent, correcting any typos, expanding synonyms, and matching it to known entities in Google's knowledge graph. The query is then compared against a massive index, a structured catalog of all the pages Google has crawled and stored. This index isn't just a giant list of websites, it's a carefully organized data structure optimized for fast retrieval. Think of it like a digital version of a library catalog with billions of entries. Pages are broken down into terms, weighted, and associated with metadata like freshness, popularity, relevance, and more. When Google receives your query, it finds all indexed pages that match the terms, then begins to rank them. Ranking is the heart of the search engine. Google's algorithms evaluate each potential result based on hundreds of signals. These include keyword presence, page quality, loading speed, mobile friendliness, user engagement, backlinks, authority of the domain, and content freshness. Machine learning models also play a role, helping to understand nuanced language and user intent. For example, if you search Apple, Google needs to figure out whether you mean the fruit, the company, or something else, based on your location, search history, and current trends. This personalization layer adds another layer of complexity and optimization. Even after the results page is sent to your browser, Google continues to work. User interaction, what links you click, how long you stay on a page, whether you return to search, feeds back into Google systems. These behavioral signals help refine ranking algorithms over time. Pages that users tend to bounce from quickly might be pushed down in future queries, while those that hold attention may move up. Let's zoom out for a moment. The entire process relies on a web of components operating in harmony: DNS for resolution, TLS for security, load balancers for efficiency, caching for speed, indexing for recall, ranking algorithms for relevance, and machine learning for interpretation and adaptation. Each piece is engineered to respond in milliseconds, scale across billions of users, and learn continuously. And it all begins with a single keystroke and a click. That seamless search experience, the one that feels like magic, isn't magic at all. It's the product of decades of engineering, massive infrastructure, and ongoing experimentation. Every time you search, you're tapping into one of the most sophisticated systems humans have ever built.